For New Shepard, we've been following an aggressive step-by-step approach from the beginning. Because it is a robotic vehicle, we have the advantage of being able to take it through an entire flight test program to make sure it's safe for astronauts. We think it's very important not only to show that we have a very robust design, but that we can repeat the feat over and over again until we are satisfied that we have enough data to fly people on it. The first time we flew New Shepard, it went to space, and we demonstrated every single aspect of the operation of the capsule for re-entry, parachute deployment, and that mission was 100% successful for the capsule. M2 was about taking what we learned from that mission, rolling in changes, and trying it again.
Engine start, we have thrust. Touchdown.
This time we stuck the landing, but we wanted to do more than just show that it was possible one time, but we needed to show we could do it again. So that was what M3 was. We turned around the vehicle as quickly as possible and we flew it again to show that we could do it again in a relatively short amount of time. For M4, we pushed the envelope. We executed aerodynamic maneuvers on the propulsion module and crew capsule on re-entry to really understand what they were capable of doing. The way that we land the propulsion module today, doing it just lighting the engine just seconds before it would impact the ground and doing this controlled landing, we perfected it at that time.
Human safety is fundamental to the design of both of the vehicles, but especially the crew capsule.
The capsule is the most highly redundant and safe spaceflight system we think that has ever been designed or flown. Every detail on that capsule, no matter how small, has been thought through carefully. We also did not compromise on fault tolerance, and that's the idea that you have redundancy, that if a system fails, you have a backup system, and in most cases, you have a backup to the backup system. For instance, the capsule is designed to be safe for astronauts if only one of the three main parachutes opens. And so we wanted to test that in real life on M5. So in M5, we intentionally did not deploy one of the main parachutes. In that situation, the retro rocket actually compensates for the higher descent rate by adjusting the amount of thrust, and it worked perfectly. Now, if the capsule is going down way too fast because it has only one parachute opening, then our third and fourth safety systems engage, which is a crushable section, sort of like a bumper. Then the seats have a scissor mechanism underneath them that has further energy absorption. The capsule has an escape system, which is designed in case there is something wrong detected on the propulsion module to get the astronauts away and get them to safety.
From the moment that we have closed the hatch, we can go escape enabled. And from that moment on, being this full envelope escape, we have very high confidence that we can keep people safe.
We've done a pad escape test where we can show that the capsule can launch and escape if there is an anomaly or an accident on the pad. The M6 mission was about testing that at its most stressing condition. We ignited the solid rocket motor in flight and showed that we could recover the capsule safely. For M7, what we introduced was a new capsule design that included the very large windows, seats, control systems on board that would control the environment in the cabin. That was the very first mission for that combined vehicle stack, and it was successful. M8 was just a repeat of M7 largely. And then the third escape test was to show that we could escape in space. So on M9, the propulsion module boosted the capsule to space, and after separation, the capsule lit off its solid rocket motor and re-entered and landed safely.
We've demonstrated with pad escape and the in-flight escape, transonic escape, that capsule escape system is solid.
Between M9 and M13, we are flying payload missions for customers, giving us even more and more confidence in the capability of the New Shepard system. 13 was a perfect flight, and we're preparing for the M14 mission, which will just be another verification and check. The overall mission of Blue Origin has remained completely the same. We are here to build the road to space